In this video, you will learn how to find the distance between 2 points and apply it to problem situation. The distance between the points x1, y1 and x2, y2 is represented by our distance formula. Let's now practice plugging in the different values and simplifying the distance formula. If I make the -3, 5 our first ordered pair, and the 4, -1 our second ordered pair, it would then follow that I could plug those values into the distance formula by doing 4 minus -3, which actually makes it addition, squared, plus the -1 minus 5 squared. If I use order of operations to simplify, we're eventually going to end up with the answer of the square root of 85. Since this radical does not simplify, and I was only asked to find the distance, that would be my final answer. Please practice it in number 2 and pause the video. In number 2, you'll notice that I actually did x1 minus x2 first. That's okay as long as I also did y1 minus y2, as I did. You'll also notice that the square root of 148 is a radical we can simplify. So, if I take a square root of 148 and try to think of a perfect square, such as 4, that divides into it evenly, that will allow me to simplify the radical in the simplest form. So now that we know how to find the distance between 2 points, we can use that to classify triangles. If we have 2 sides that are congruent, that would give us an isosceles triangle. If you have all 3 sides congruent, that's an equilateral triangle. If there are no sides congruent, you have a scalene triangle. So if you find the distance between 2 of the vertices of the triangle, and then look at those 3 distances for each side, you should be able to classify the triangle. So let's start by finding the distance between A and C. So the distance between A and C would be the square root of 4 minus 2 squared plus 6 minus 1 squared. Again, by following order of operations to simplify, I eventually get the answer to be the square root of 29. Next, let's find the distance between A and B. Go ahead and pause the video and practice. Once you have checked your answer for the distance between A and B, go ahead and find the distance between the vertices B and C. Again, pause the video. We can see that the distance between sides or vertices B, C is the square root of 29. Since it was the same distance for the length between the vertices A and C and between B and C, we know that this triangle must be an isosceles triangle. Now use the same example and do number 4 on your own. Please pause the video. We can now see that the distance for each side is different. DF is the square root of 26, DE square root of 29, and EF a length of 5. Since all 3 lengths are different, examples for triangle is a scalene triangle. We also want to be able to find part of a point given the rest of that point, another point, and the distance. So again, I'd remind you of your distance formula. If we simply get rid of the radical by squaring each side, that's going to give us d squared equals the difference of the x values squared plus the difference of the y values squared. At this point, we can plug in what we know. And again, use order of operations to simplify. And this gives us the solutions of x equals 0 or 4. Please pause the video and do number 6. Please check your answer.